Now let us solve exercise 5.4 and question number 1 is differentiate with respect to x e raised to power x divided by sin x. Okay. So let us see how to differentiate it. Now y here is e raised to power x divided by sin x. Now you see that it is in the form of u by v. So I need to use quotient rule. So using quotient rule. What is quotient rule? D dx of u upon v is v square v d dx of u minus u d dx of v. Okay. So d dx of ex by sin x will be your sine square x. You know sin x whole square is same as sine square x. And it becomes sin x as v is sin x d dx of ex minus ex d dx of sin x. What is the derivative of ex? Derivative of ex is e raised to power x itself. Okay, so it becomes sin x into ex minus ex, and the derivative of sin x is cos x divided by sine square x. Okay. Now what can I do is I can take e raised to power x common from the numerator and it becomes sin x minus cos x divided by sine square x. So d dx of e raised to power x divided by sin x is your e raised to power x sin x minus cos x divided by sine square x. Now very one important thing is that this will exist only if the denominator is not equal to 0. So you know what angle value will make it 0? That means x should not be equal to n pi for all n belonging to z. Okay, for this value, this derivative exists properly. Okay, now question number 2 is differentiate. You have to find the d dx of e raised to power sine inverse x. Okay, so how do we differentiate it? We will differentiate it with respect to x. That means firstly I need to treat it as e raised to power x. Okay, and then I need to take the derivative of sine inverse x. See how it happens when I differentiate e raised to power x. Actually, how differentiation happens, that firstly I need to differentiate this e raised to power x and then I have to do d dx of this x. Okay, now as d dx of x is 1, so that's why we get d dx of ex as e raised to power x itself. Now when I need to differentiate this, okay, what will I get? I'll get it as, treat it as e raised to power. So it will be e raised to power sine inverse x into d dx of sine inverse x. Okay, now you know what is d dx of sine inverse x? It is 1 upon under root 1 minus x square. So I'll get it as e raised to power sine inverse x into 1 upon under root 1 minus x square. Okay, so that means the d dx of e raised to power sine inverse x is e raised to power sine inverse x divided by root 1 minus x square. Okay, question number 3. Now question number 3 is differentiate e raised to power x cube. Now similarly as we did it in the earlier question, so how will it go? It will be your, firstly treat it as ex. So it will be e raised to power x cube. Okay, e raised to power x cube into d dx of x cube. So it is e raised to power x cube into 3x square. So this is 3x square into e raised to power x cube. So this is the required derivative. Okay, this is how we differentiate it. Question number 4 is your find the d dx of sine tan inverse e raised to power minus x. Now how will we differentiate it? Now see it carefully. You know, first term is, I have to apply the chain rule. First term is of this sine along with this everything. Then the term is of tan inverse. Then the term is of this function e raised to power minus x. And at last the term of minus x. As you know, d dx of x is 1, so everything gets adjusted, but derivative of minus x will be minus 1. So if I'll not take it, negative sign, error will be there. So see, how will I differentiate it? Firstly, this sign will be differentiated as cos. So it will be cos of this complete thing. Okay. Sign result is first derivative is cos. Then derivative of this tan inverse. Okay. Now I have to take the derivative of this complete term tan inverse e raised to power minus x. Okay. Let's go a bit slow. So it becomes cos of tan inverse e minus x into, what is the derivative of tan x? Tan inverse x, you know, the derivative of tan inverse x is 1 upon 1 plus x square. Okay. So this is the formula box which is there. So it becomes 1 upon 1 plus, who is x? X is this. X square means e raised to power minus x whole square, that is, it is e raised to power minus 2x. Then the derivative of e raised to power minus x. Okay, see how we are finishing the lines. Firstly, this sign is treated cos, then this internal tan inverse is treated, so that is 1 upon this 1 plus x square, and then into d dx of this e raised to power minus x. So it becomes cos of tan inverse e minus x into 1 upon 1 plus e raised to power minus 2x. Now the turn of derivative of e minus x is, you know, it is e raised to power minus x. Okay, but what is the derivative of e raised to, say, now it will be like d dx of minus x. What is it? It is minus 1. So I will just carry out it as minus times cos tan inverse e raised to power minus x, okay, into this x, this minus x is treated as derivative is minus 1, and this will be e raised to power minus x, okay, divided by this 1 plus e raised to power minus 2x. Okay, so this is how we will differentiate this function. Now the next is question number 5, and question number 5 is your find the derivative of question number 5 is find the derivative of d dx of log cos e raised to power x. So first term is of this log, then is of this cos, then is of this ex. Okay, so it becomes, stop. Now question number 5 says differentiate y is equal to log of cos e raised to power x. So let us see how to differentiate it. So differentiating with respect to x. Okay, so firstly the term is of log, then is of cos, then is of ex, and then as x is x, so it will be simply e raised to power x. Okay, so let us differentiate it. Dy by dx is equal to, now the derivative of log x is 1 upon x. Okay, so it will be your, now this is log of this is x, so it will be 1 upon cos e raised to power x d dx of, okay, cos e raised to power x. Clear? Log of x means it is 1 upon x and then d dx of cos ex. So it becomes 1 upon cos e raised to power x. Now the term is of cos. Cos will be minus sine e raised to power x and then d dx of e raised to power x. There is no need to do d dx of x because that will be 1. So what is the derivative of e raised to power x? You know it. It is e raised to power x itself. So it is minus sine e raised to power x upon cos e raised to power x into ex. Okay. So either I can also write it as minus e raised to power x tan e raised to power x. So this is also the solution. Okay. Question number 6. Question number 6 is differentiate e raised to power x square plus so on so e raised to power x5. Okay, so let us differentiate it. This is y. So dy by dx is equal to differentiating with respect to x. So I have to take it like ddx of e raised to power x square, so on, so ddx of e raised to power x5. So as we have done in question number 3, so this question will proceed like, so what is the derivative of e raised to power? It is e raised to power x, and the derivative of it, firstly it is e raised to power x square, and then ddx of x square, that is 2x, plus so on, so it is derivative is e raised to power e x raised to power 5, and ddx of x raised to power 5 is 5x raised to power 4. Okay, so you can just summarize like 2e x square into x plus so on, so plus e raised to power x5 x4 5. Okay, so this is the way how you can differentiate number 6. Number 7 is differentiate y is equal to root e root x, where x is positive. Okay, you know why this condition is there, because this will exist only if the result coming out of here is positive. Okay, so let us differentiating with respect to x. So dy by dx is equal to, now ddx of, say how are we going to take the derivative? I have to take, say this has power 1 by 2. Okay, and I have told you how to take ddx of some root, that is 1 upon 2 root x into ddx of what is inside the root. So here it is not required, but if it is there, so it will be 1, so I will get it as 1 upon 2 root x. So this is the way how we differentiate the square root functions. So let us start with it. So it is something e raised to power root x. So what is the first, how will I take the, say suppose it is say root x. So what is the derivative of it? It will be 1 upon 2 root of e root x. Okay, and then ddx of this thing, ddx of e root x. So it is 1 upon 2 e root x into the derivative of it will be, you know, e raised to power x is e raised to power x itself into ddx of this root x. So it will be 1 upon 2 e root x. Okay, it is e root x, and the derivative of root x discussed here is 1 upon 2 root x. So I can write it as e raised to power root x in the numerator, and it is 4. Okay, 2 to the 4, root x root e root x. So this is what we get by dy by dx. Okay, now question number 8. Question number 8 is there, and question number 8 says, question number 8. So question number 8 is your, find the derivative of y is equal to log of log x, where x is greater than 1. So let us differentiate with respect to x. It will be dy by dx. This is equal to, first term is of this log. What is the derivative of log? It is 1 upon log x. So it will be 1 upon, say if it is x, then it will be 1 by x. Okay, now since it is log of x, in place of x we have log x, so it will be 1 upon log x into ddx of this log x. So it is log x. Clear? Because ddx of log x is 1 by x. So it is 1 upon log x into the derivative of it is again 1 by x, and there is no need to do ddx of x as it is already 1. So I get the derivative as x log x. Okay, and this condition holds for when x is greater than 1. Question number 9. Y is equal to your cos x log x for x positive. You have to differentiate it. Again, it's the question of quotient rule. Okay, so differentiating using quotient rule, how will I go? Log x whole square log x d dx of cos x minus cos x d dx of log x. Okay, so log x, derivative of cos is minus sin x, derivative of log is 1 upon x. So this is minus sin x log x cos x upon x into log x whole square. Now what can I do is I can take the LCM. So it is minus x sin x log x minus cos x, and this x in the numerator can be written as x log x, only log x whole square. Okay, so this is our question number 9. Okay, now what is your question number 10? Question number 10 says you have to differentiate cos of number 10. Question number 10 is y is cos of log x plus e raised to power x, where x is greater than 0. Okay, so let us differentiate it. Dy by dx is equal to, okay, first term is of this. Okay, one thing is I can either open it or I can just go like this only. So means open it means I can just write it as, say, cos log x plus cos e raised to power x, that way, or I can just go by this also. So say I am going by this way only. So it is cos of something, the derivative will be minus sine of this complete thing. Okay, into d dx of log x plus e raised to power x. So it is minus sine log x plus e raised to power x into the derivative of log x is 1 by x and ex is. So it is minus sine e raised to power x plus log x, say I arrange it in that way, into this is 1 plus x ex divided by x. So this is how we find the derivative of x is greater than 0. Okay, so this result is holding fine. So these are the solutions of your exercise 5.4. I hope everything is clear to you.